Hi, ladies and gentlemen. Today we are going to approach a Docker. Docker is the reason we actually using Docker is because in our AWS containerized systems we have Amazon Elastic Container Service, which is actually a Docker, and the repositories where we put our Docker images are here. The only important part here is that our Docker file, which we're going to use to create a Docker image, must have ECR Amazon Linux template. So when I develop it, I call it vanilla, and then we're using, as a systems engineers, we want to keep everything consistent, everything secure. So in that particular instance here, we might as well this is the basic one, this is the basic Docker file, but we might actually go to the extent of creating a vanilla to be a very secure container. So initially we can just get a vanilla image like that, install some basic updates, upgrades, and packages which we really want to use it for our application. We can also tighten it or harden it, as it's called. So we can actually run whatever's required to harden our system, to make sure that our system has keys, SSH access, or it doesn't have SSH access, to make it as secure as possible. So this is what systems engineer's job is a consistency and reliability, and obviously a responsibility. So looking into the next Docker file, I call it Docker file my app, because we have a my app directory in here, and here we actually store our application, which I just, for our testing purposes, I've just downloaded from the GitHub. I found this application of task manager. So as of, for example, a builder or a farmer goes around and ticking up what he needs to do on his mobile phone and saying that I need tomorrow to do this task, and this task, and then delete it by the time. Just a very simple application, basically. Doesn't have to be complex as a work application, work example. But most important thing to keep in mind that in this case we could implement actually a few different things: the hardening of the computer, hardening of the container, or testing, whatever requires by our company. Okay, so we're doing that. For the purpose of doing that better, I've created a Makefile, and this Makefile can actually deploy the whole infrastructure. As we can see here, deploy all can build an image, which is number one. So this is what we're doing. We building an image, then we can make AWS based infrastructure like a cloud and a few other things which we need, IP addresses, etc. Then we're pushing our image, and then we can set up, let's say, ECS infrastructure. So we can add the load balancer and let's say ECS, which is a Docker, which is a containers, just a touch base. One more time, we've got repositories here. And in these repositories, this is where our Docker image is going to sit. We can view the push commands after the repository is created, and this is what basically Terraform does. We don't need to do it. We can even open the Visual Studio, right? And in Visual Studio, like in this one, we can ask to create a Terraform infrastructure through our chat with AI, as an example. And AI can deliver us the all required files. all required files to do the Terraform infrastructure. Obviously the basic one, but starting up from, so it improves our performance. Okay, so let's do it. So I'm going to turn off my video and I'm going to turn off my sound. What else I'm going to do? I'm actually going to pretend that my LXC container that actually carries out the Docker inside by special characteristics or special configuration called nesting. So this LXC is actually, or LXD in Linux is actually a powerful open source tool. I know that it's actually used for Australian tax office. It's actually not that not that weak, so it is pretty powerful thingy. Anyway, so very powerful, computer containerized solutions and the virtual machines. Yeah, okay. So basically, we can start doing it, yeah. So let's get on to it. Let's get on with that. Okay. Okay, so as you can see, what we've done is we initially assumed simply that the container is broken, the Docker isn't working in the container. So what we've done is we used LXC restore from the snapshot. And this is why it is very important to have the containerized solution in your on your desktop. If you would be running a test environment on your root directory, when you update, and let's say you're using the older version of Ubuntu, when you're updating it to the newer version, it's very likely that your Docker is going to break. And plus, I'm using 2204, which is 2 years old version of Ubuntu. Now, if I wanted to update or to use the newer version of Ubuntu, I can just install a container with 2404, which is what I'm currently using. So my containers, so if I look at my containers and I go into LXC list, gives me the containers like these. All of those containers are 20. Actually, some of those containers are still 2204, but I'm pretty sure that DO control, Docker control, is actually 2404. So here you go. It's you're using latest solution for your testing environment in your older laptop, because desktop is one thing which you're using every day. You use emails, you're using other, including music, etc. But your containers, they isolated. They specifically for only one purpose, is to make money for your company, to be a good software engineer, to be good systems engineer. So this is what we're doing. So I have assumed that my Docker has broke in my LXC container, and I restored my LXC container. Now, as soon as I went to my files, to my container, I realized that after having after going back to restore point of the 1st of September, and now it is 9th of November. So we need to update our repository, and with only one command, which is git pull, we're getting latest file, and our container is now ready to be used, as never broke down. So this is very good, and this is why people using containerized solutions, it is probably the best way. So anyway, so let's go back to a system. So after I've done that, I ran make build image, which actually went through the transition of going creating a vanilla image from AWS Linux and installing on this container, on the Docker container, vanilla Docker container with AWS Linux. Where here you go, and you can even use another operating systems for within the containerized solutions, which is also another point. So you can be a productive and very good engineer. Here you go. So, and then after that, the Makefile removed my Docker file, and then we copied application Docker file, and here you go. We built an application image. We can now, after we built it, here you go, we've got two images. One is vanilla image, why we've downloaded to save money for the company, to be consistent. We want to make sure the list of just cutting it short in putting the point in there, we've got we can build a vanilla system which is required for our company, as hardened as we want, and with packages which we want. So if our development team work with a PHP, we put PHP software, PHP compilers on it, and if our company uses Python, then we install the latest Python. And actually, this is what does Infra Dojo. This is one of the companies that actually created a 2 gigabyte worth of container that actually really good to deploy a Python applications for this particular company, compile and roll it over to the Amazon. So here you go. This is the real stuff for systems engineers, for DevOps engineers. This is where we can see. But I'm actually over to a simple points. What I'm doing today is just an example for you guys to get a job, for us to get a job in Australia, so you can show your skills. So here you go. So we actually, then after this, I ran I ran the application on the port 8000. I could direct it to the port 80. And here you go. It started to run. So later on, you can always stop your container, start your container, restart your container, and if you can see that container is running on this port, you can delete it. I made aliases. I made the LXD CRM, which deletes all of the containers, and I also have another one that deletes the images, all of the images, apart from Dojo, because I need this Dojo for work, and my testing containers for this particular example, all others I delete. As you can see, this is what I do. I grab -v, the Dojo, and I even giving the ID as well, or ID. So what else I wanted to show you is that the application is actually running. So we achieved what we wanted to achieve. So now this application with Makefile, now Makefile can deploy the Terraform after ECS infrastructure, etc., with the load balancing, which we're going to take over to look into in the next tutorial. So next lesson or next video is going to be about load balancing and Terraform deployment, building up infrastructure, Terraform basic infrastructure, and we can, so we can do that. We can also push the image. So this is also a part of deploy all, because initially we have to, before we push image, we have to set up a repository. And this is why it's called Terraform Infrastructure as a Service. So we actually have those files that actually creating us an infrastructure with the right IP addresses, with the repositories. And after repository is created, like what I can actually show you here. So we've got the repository, that repository. After the repository is created, we can simply upload our image, and this is what you will see. So we will upload that image into a repository, and now, like this application which is currently running, like that container application, we can delete things, etc. It's for the testing purpose. So when a developer, like it's a good practice, like if you're a systems engineer, you want to make sure that a development team, the guys who develop software, their software is actually running on your container. So you're actually incorporating in your container. You can deploy this container in your own Docker. And you can see that on port 10.0025 it actually works. So you can then deploy it, because our initial container, as you saw previously in here, in that in the X term, is actually, it actually says it was running on the port on all of the IP addresses. So, good practices back then again. So, yeah, going back to AWS, we've got a repository where you will see on pretty soon our image landing, and then from this repository we are going to create clusters with tasks and etc., and then we're going to EC2 where we're going to set up the load balancer, but we're not going to set it up ourselves. The Terraform is going to do it for us. It's just we're going to, after it's created, like if load balancer is created, sorry about this red flags over here. It's because I'm actually it's nothing to do with me. it's just my slow internet at the moment. I'm having a bit of an issues, and by the look of it, my file, my internet and HTML is marking it all as red, but in reality it's not red. Anyway, it's still trying to do things. By the look of it, I've lost the internet. But I didn't lose my own internet, which is most important thing. So I can show you the task application which we actually ran. But in any case, let's go back to this. In repository, we ending up with our Docker image, and then we are going to deploy that Docker image already then in ECS, in the services. Okay, so basically that concludes our today's quick introduction to a professional systems engineering, bit of an introduction tutorial, and good luck with learning more and staying a professional. Thank you very much for your attention, and see you next time.